If you're a software developer, you likely know that for a program to work, it needs a lot of resources, be it threads, network connections, or even as small as memory to store data. Internally in the code, as variables serve their purpose, so should the associated resources be cleaned up. After all, they're not unlimited. While most languages do this automatically, there's one in which you do all the work yourself. The name of it is
C!
In C, the cleanup is a very tedious process, especially when multiple resources are involved. So it would be nice to automate it at least a bit. What was proposed to the standard is a defer statement, similar to the one in Go or Zig. Twice. And both times it was rejected. Does that mean that we're missing out on such a cool feature? Well, not quite. There's a language construct that will help us achieve a similar behavior in C. And I'm talking about the for loop.
Huh?
To understand what I mean, let's look at how the for loop is structured. The first part is initialization statement, but it is not relevant for now. The second part is a condition that is checked on every iteration, just like in a while loop. What's interesting is the third part. It is an expression that is executed at the end of every iteration. You probably have seen this form before. Here, the third part is an increment operation. But you know what also happens to be an expression? A function call. In fact, if we wanted to, we could print hello world like this. My bad, like this. Okay, even at this point it works as intended, and we can put any function in here for cleanup. However, before I turn it into a macro, I'd like to get rid of this I variable, because we will need the first part for later. There's an interesting detail about how statements work in this language. Imagine you have some code. Nothing special about it. If we put it inside an if statement that is always false, the code will never execute, which sounds reasonable. Next, let's try to unconditionally jump into it, which can be done with goto, for example. Unsurprisingly, now this code will behave as it used to. The point of doing this all is that now that we're inside of this block scope, we've obtained all of the properties of the block scope. So for example, an else statement would not execute. For various reasons, goto is evil. So let's replace it with a switch statement. And now we can finally combine this and the previous for loop. But hold on, this looks familiar. What we've created is known as a Duff's device and is usually used for loop unrolling. But this version will run one iteration, execute the third part, and then leave the loop. As a last touch, we can remove the curly braces, thanks to chaining statements. Notice how the default case label is still there. That's because it is ignored as a statement. And at last, we can turn it into a macro. Interesting interactions happen with the existing keywords. For example, continue will allow us to go straight into the cleanup process, while break will exit the scope without invoking it. Return is problematic, however, because it will leave the function but not invoke the cleanup process. The solution to this is to create a macro that will replace the keyword and will invoke an error when we are inside of the scope. Unfortunately, this solution is undefined behavior, and some compilers may not allow it. And there you go. This is how we do defer statement in C.
Dear God.
There's more.
No.
Now, all of this has been possible since the very first standard of C, C89. And this handmade defer mechanism is pretty solid on its own. But here's a catch. Even though it is used for cleanup, it doesn't prevent the use after free errors. Theoretically, we can span the entire function so that the destruction process happens at the end of the function. But let's be real, it still doesn't give a guarantee. With newer features of C, however, it is possible to create a more powerful cleanup mechanism. One of them was already mentioned, it is the first part of the for loop. Since C99, it is possible to declare a variable in there, which will be present for the duration of the entire scope. That's precisely why we left it empty. Another unique feature of modern C is the generic selection. It selects an expression based on the type of the first argument, which is very reminiscent of template specialization from C++. Just not ugly. As you may remember, the function calls are expressions, but in generic selection it is common to use the function names instead. Why? Because function names decay to pointers. As such, it is possible to use the common interface while also having different function prototypes. We can put the generic selection in place of the third part. As such, it will select the destructor based on the type of the variable we're creating. The destructor list can also be specified before including the header via a macro define. So now the new interface looks like this. The first argument is the type. The second argument is the name of the variable. The third argument is the initializer. And the fourth argument is optional. It is needed to specify the destructor in case we're not satisfied with the default one. The resulting scope behaves similar to a unique pointer, except it obviously doesn't have move semantics. Anyway, now that we've gone through all these hoops to implement this, is it even worth including in your project?
No.
Well, yeah, this is a proof of concept, but it has many flaws. For example, it creates a lot of nesting when managing multiple resources. Also, the destructor addition is very clunky. And lastly, it is probably going to be irrelevant. Remember how I said that there were 2 attempts at making the standardized defer model? Well, it's actually 3 now. And it seems like 3rd time's the charm because it is being actively pursued. And I must say, out of the go-to paradigm, whatever I've made, and the non-standard extensions, the proposed solution is probably the best version of the cleanup mechanism. In reality, defer is only a partial solution to the problem, since C doesn't have neither garbage collection nor move semantics along with RAII.
What?
Moreover, defer is unlikely to make the language any safer, since even according to Rust, memory leaks, deadlocks and whatnot are considered memory safe. But in any case, I hope this video taught you anything, and remember, you can't spell heresy without...